Hello Planeteers, my name is Siyabonga Nozwane and I'm studying towards my honors degree in geography at the University of the Witwatersrand. So on our exciting core talk today, we're going to be looking at plate tectonics, discovering the world's biggest jigsaw puzzle. Let's get back to it. So on the hierarchy of models, we're going to be looking at drifting continents, which is in stage 4, whereby we'll be covering aspects such as climate changes, ice ages, and human evolution. So the overview of this lecture, we'll be talking about the structure of the Earth, plate tectonics, what impacts do plate tectonics have on climate change, how do plate tectonics influence the habitability of the planet, and what is South Africa special in terms of plate tectonics. The structure of the Earth, we have the crust, we have the mantle, we have the outer core, and we have the inner core. So we have the crust, which is basically where we live. The crust consists of two aspects, one which is the continental crust and the other which is the oceanic crust. The continental crust, it is buoyant and it is land, and the oceanic crust, it is more dense and it is oceans. Then we have the mantle. The mantle lies just beneath the continental crust. The mantle consists of hot, dense silicate rocks, and it provides thermal and mechanical driving forces that drive plate movement. And then we have the core. The core is the Earth's innermost part, and it is also divided into two, which is the inner core and the outer core, which are both responsible for the geomagnetic fields of planet Earth. So what are plate tectonics? So if you look at the world map, you may notice that continents fit together like pieces of a jigsaw puzzle. Hold on to that thought. We will get back to it later on during the course of the lecture. So what are plate tectonics made up of? So plate tectonics are made up of the lithosphere, which is the crust and the upper mantle, and the asthenosphere, which is the layer of solid rock. So pioneers of the plate tectonic theories. So we have a man named by Alfred Wegener, who in 1912 came up with the theory of continental drift. The continental drift theory states that continents are at a constant motion. And in 1929, a man named by Arthur Holmes came up with a supporting theory whereby he named it convection cells theory, whereby it states that the activities within the mantle are the driving forces of continental movement. So as mentioned before, that parts of different continents fit together like pieces of a puzzle. So 225 million years ago, we had Pangaea, whereby it was a supercontinent and all continents were intact. And 150 million years later, it divided into two, which was Gondwana, which consists of South America, Africa, India, Australia, and Antarctica. And we had Eurasia, which consisted of North America, Europe, and parts of Asia. And today we have 7 different continents which are widely dispersed, and scientists have proven that the continents still are in constant motion, and it is a great fact that Africa is being divided into 2 continents. I know. So what evidence do we have of continental drift theory? So one, continental edges fit like puzzle pieces. The second one, same fossils are found on different parts of the continent, or different continents rather. And then we've got climate that is seen in evidence from continental ice sheets. And lastly, we've got rock structures that shows similar features in different continents. So what causes plates to move? So we've got number 1, the convection current, whereby chemical activities occur within the mantle. So this occurs when the warm mantle current drives drives and carries tectonic plates like a conveyor belt. And then we've got the ridge push force outwards, which is the outward push, whereby the upwelling of magma rises and forms new crust, which pushes away the old and dense crust. And then we've got the slab pull force, which is the inward pull, and it is the older and colder plates that sink at the subduction zone because of when they cool, they become more dense and therefore pulling away the newly newly formed plates. And then we've got the type of plate boundaries. So what are the different types of plate boundaries? So we've got the divergent boundary, whereby plates move further apart from each other. It occurs at oceanic plates, and it usually causes rise in mid-oceanic ridges and causes catastrophic disasters such as tsunamis, earthquakes, and volcanoes. Then we've got the convergent plate boundary, whereby plates move towards each other, and it usually occurs beneath the continental plate and at the subduction zone, and it causes fold mountains, right? Then we've got the transform plate boundary, whereby plates move sideways to each other. In this plate boundary, lithosphere is neither created nor transformed, and it also causes earthquakes. So what impact do plate tectonics have on climate change? So it alters ocean currents. This happens whereby in the case of a volcano or tsunami, and water currents are redistributed. Say for instance, in a place where you found warm ocean current and a tsunami occurs, the water is redistributed to another place and it alters ocean currents. Then we've got more glaciers over land, and that increases the albedo effect, and it also has a change in long-term climate, which was touched on by the paleoclimate lecture, and I will further on explain it. So this graph consists of a deviation of Earth systems in the form of gaseous exchange. So if we look at 250 million years ago, Pangaea, and we look at 50 million years ago, we see a change in the temperature. So about 50 million years ago, the continents assumed their current configuration, which prevented oceans from buffering changes into the climate as they did previously, therefore resulting into global cooling, also known as the Ice Age. So why is South Africa special? So South Africa, number one, is located at the Africa tectonic plate, and not only is it located at the Africa tectonic plate, it is located at the central region of the Africa tectonic plate. Therefore, we can conclude that South Africa is relatively stable compared to other places. However, the biggest earthquake that has occurred in South Africa measured a 6.3 at the Richter scale in 1969 at Ceres in the Western Cape. So how do plate tectonics influence the habitability of the planet? So number one, land distribution. In cases of earthquakes, we have fold mountains, we have new ridges that are formed. Land distribution is formed, and land use changes. And we've got the emissions of greenhouse gases, whereby we have volcanoes which emit carbon dioxide into the Earth's atmosphere. And then we've got the formation of new minerals, whereby new minerals is pushed from the beneath the Earth to the crust. And in conclusion, the Earth consists of the mantle, the core, the outer core, the inner core, and the crust. And plate tectonics describe the Earth's outer shell. And we have the convergent plate boundaries, divergent plate boundaries, and transformed plate boundaries. Stay tuned to the next core talk, whereby I'll be talking about human evolution. Thank you guys. Enjoy.